Thank you, Bing, for a great presentation. I'm so happy that we at Alpha Intelligence are your shareholder. I'm joined here by a phenomenal panel, starting with Noor, and going on to with Paul, Derik, and Alex. And we're going to talk about why deep technology matters and how we make it work or not work. So I'll ask everybody to take 30 seconds to introduce themselves. Noor, how about you start?
Hi everyone, I'm Noor Shakir, CEO at GTN. We basically combine quantum physics, machine learning, and drug discovery to teach machine to design novel chemicals from scratch by going into the fine granular details, understanding the atoms, the biology, and then from there up, designing drugs that are more potent, more efficacious, and faster and cheaper.
Thank you. Paul?
My name is Paul Master. I am the CTO and co-founder of a processor company in Silicon Valley known as Cornami, and we're fundamentally reusing transistors in a different way to accelerate machine learning applications.
My name is Derik Pridmore. I'm the CEO and co-founder of Osaro. It's actually Osaro, not Osaro. We do machine learning for industrial robotics, and prior to that, I was a venture capitalist at Founders Fund in San Francisco.
Alex?
Hello, my name is Alex Lyashok. I'm CEO of a company called WorkFusion. We make software that is called Intelligent Automation Cloud. Enterprise companies rely on it to automate their operations. They create smart bots that make their business processes smarter.
So there's a fun story we are, let's say, a half a kilometer away from DeepMind. And I was fortunate enough to be involved in the Series B DD of DeepMind years ago. But there's a guy on this panel here, and that's Derik, who was involved even earlier. So Derik, you led with Founders Fund when you were there. You led Series A at DeepMind. And obviously at the time, this is almost 10 years ago now, DeepMind was just a complete outlier. It was a research outfit. So I want to ask you, what convinced you in there to invest in Demis and his team?
Well, the short answer is the team, but it was an audacious pitch. In 2010, I'd been looking for deep learning companies for about 6 months and talking to academics, and we hadn't really found anything that we thought was investable. And then after a Singularity conference in San Francisco, Demis came to pitch Peter Thiel, who I worked with, and Peter pulled me in. So we sat down with Demis and Shane, and they basically pitched a very detailed research plan, at the end of which they basically asked for $20 million and said they were going to do research for 10 years and solve AI. And I think it's interesting that we're almost 10 years out now. And we sort of sat back and said, interesting. We didn't say no, but we continued talking to them, and we essentially helped them formulate at least a few product ideas that we thought were investable around games, which was Demis's original background. And those wound up becoming tools that the DeepMind team used internally in the beginning to benchmark some of their algorithms. So obviously they went on and did the research thing and built a hugely successful research center.
Would you still do it today? Would you, in this environment, at this stage of the industry and its maturity, would you still invest in a DeepMind-like company?
I don't know if you could do it in AI. At the time, the reason why Demis and Shane and Mustafa were so compelling was that they'd been previously successful entrepreneurs Demis had. They were technique agnostic, so we knew about deep learning. They were teaching us about reinforcement learning and other ideas that they had that were brain inspired. So the idea of being not married to a particular technique, I think, was interesting, but to do that today in machine learning would be very difficult. I think it wouldn't be possible.
So I think we have a request from the audience to increase the volume. Is that right? Yeah, all right. Pump up the volume, guys. Volume. Thank you. All right. So I want to shift gear for a bit. Noor, so we have, backtrack for a second. We've got London, San Francisco, New York here on the table. So it's an international group, and yet we face the same problems. So let's talk about deep technology. What makes you believe, Noor, that to go and build your company, you needed to invest deeply in the technology space, as opposed to taking a TensorFlow or a PyTorch, a framework, a usual framework, and just try to build it from the ground up.
I think it was mainly because of the scale of the problem that we would like to solve. Drug discovery in biology is very complex. You can't really take off-the-shelf technology and kind of hammer it on the problem and kind of it will magically work. This is not really, I know like some people think about AI and machine learning in that way. I don't really think that applies to biology and drug discovery. We really had to go back and think about the fundamental to the problem, and that included bringing like chemistry knowledge, bringing in drug discovery knowledge, bringing physics knowledge in terms of understanding the molecular biology of the thing that we would like machine to learn about, right? So it's kind of thinking about what we're trying to learn, what we're trying to teach machine learning about, and then building the right tools and the right technology on top of that. And that does not really happen in kind of taking off-the-shelf models, getting it to work, like throw data on it and expect it to work. So you had to think about what kind of team you need to assemble to think about those issues and then to scale the machine and to build the technology that allows you to do that.
And for you, Alex, is that the same problem, or you started from the application on down?
When companies use our technology, they apply it on the scale of one person's job. Think about a data clerk in a bank processing documents every day. We don't really have a big data problem at that scale. We have a small data problem. And the truth is that a lot of the technologies that are being researched and algorithms that are published, they simply don't work when the amount of data is very small.
Right.
And so a lot of progress has been
learning
made
on small data
over the past year with big supervision and other federated learning, other techniques, and those techniques still need to be further developed to get to the levels of performance.
So for you, the key was there's nothing out there that enables you to learn on small data sets.
Size is one component, but also if you're a bank or you're an insurance company, not all of them, there are trust issues at play.
Right.
Not all of those organizations are actually have degree of conviction to put the data on the Google's platform. So they need to be able not to just run it at a very small scale, but also do it within the infrastructure that they own today. And bank doesn't have 1,000 GPUs lying around, and many of them don't even have cloud deployments.
Yeah. Few people have 1,000 GPUs laying around, right?
That's right.
I guess the same for you, right, Derik? Small data sets, different types of process problems, you need to pick different types of objects. Can you explain what you do? I think it's a very cool application.
Sure. So we have a couple different technologies in Osaro. We started with deep reinforcement learning, which was something I watched the team at DeepMind build. And we had I wouldn't recommend starting a company this way, but we started with the technology, went out and found a bunch of problems. Luckily, deep reinforcement learning applies broadly. We did some early work in robotics using a neural network to directly control a robot. Subsequent to that, as we productized, we built out a lot of specialized technology. So we do a lot of deep learning and deep reinforcement learning. We also develop a motion control stack, which I'll talk about tomorrow. And then a lot of just really hard integrations to customer systems. So essentially, it's an autonomy stack for industrial robots. Industrial robots are in much the same position as your car. It comes with a lot of software, but it doesn't drive itself. The same is true for industrial robots. They don't come with eyes, and they can't really move around intelligently in an environment. So we build a stack that does that, and we license it to materials handling integrators who want to do things like Amazon-style fulfillment operations. And for me, the key, I guess, when I think about deep tech is either a problem where you're bringing together very disparate technologies, and you need to do a lot of hard research to understand how to put them together, or inventing a tool. So the difference between hard tech and deep tech and something like payments is that with payments and a lot of engineering, in principle, the tools that exist work, although there's a lot of engineering to do. But with a lot of deep tech, you have to invent your own tools to either analyze small data sets or to sort of uncover new molecules, things like that.
So you mentioned something, you said just hard tech. So I want to talk about hardware. Because we all talk about software being, we live in the world of agility, where you can just release, learn, just the fast track to innovate and iterate. But in hardware, it's different. Hardware, if you misfire, you're in deep doo-doo. So, Paul, is hardware hard tech?
Hard tech, yeah, it's very hard tech. In fact, it's the painful tech of everything that's
Painful
all
tech.
the software that builds on top of it. And I'll give you an example. So machine learning is an interesting algorithm. And until somebody, 2015-ish, we can argue the date exactly, but it's fairly recent, tossed the horsepower available of a GPU, it made the algorithm real. And, you know, we're humans, and we don't quite understand what just happened, but our machines can now outdo a human in visual pattern recognition, which means this particular algorithm will go everywhere. And we do not know as a society where everywhere is yet. But it was driven by accident using a GPU. A GPU is a hideously inefficient machine to actually run machine learning. So we looked at this and said, is there a phase change in the industry now? Is it the time for a new type of architecture to actually drive this type of application forward? And that's the hard part, is coming up with a new architecture, building it, getting it out into market.
And how can you be agile while being in hardware?
Okay, so...
Is that possible?
Yeah, it is possible, actually. And agility is a pyramid, right? You start with an algorithm. You have to innovate at the algorithm level. Below that are the hardware pieces, and you have to innovate at every level. But let me give you guys a hard example. So many years ago, I had the privilege of working with a brilliant gentleman by the name of Eugene Hogenauer. Gene built an algorithm known as the Hogenauer filter. Okay, that's not familiar to you guys, but you are familiar with one of these devices. Hogenauer filter, CIC filter, is in every cell tower on the planet. And it's an algorithm, but it's a better algorithm, and I'll explain what that means. So in the good old days, the only way you could do up and down conversion, i.e. take the signal, put it up, take the signal, put it down, is using an algorithm known as a fast Fourier transform. An FFT uses a multiplier. Hogenauer filter uses adders. It's 100 times more efficient, meaning I can put 100 times more channel, I can reduce the power consumption by 100-fold. So that's an example of innovation at the tip of the pyramid. So you innovate at that pyramid and you get 2 zeros, and then you innovate at the layer below it and the layer below it.
So I want to ask about timing now, because you know these things just don't happen immediately. They take time. The convergence of these different requirements as well as technologies take time to happen. So Alex, for example, in your case, what compelled you 10 years ago now, roughly, to start WorkFusion? What was the combination of factors that made you think this is the time?
I mean, I think, even at the previous panel, Eric talked about the fact that technology that we have available today can get at the complexity of problems that people still work on. Mm-hmm. There is hundreds and thousands of manual jobs today in the world where people complete mundane tasks. And it's the desire to change how the work is done today and free up people from those manual tasks that is the genesis of our company. We essentially allow people to spend their time on something that is more creative, more valuable than doing data entry. But of course, there is still a lot of very difficult technological problems that were needed to be solved to understand that. We work with data sets that are not available. They're locked up in these small pockets within enterprise companies. They're not shared. They're not available as open data sets. And so to build a business that will have the trust and the technology to be able to get access to that and help people solve real problems, that took a while.
How about you, Noor? When did you start the business?
2017.
17, so 2 years ago. So 2 years ago, you're saying, I'm in a video game space. I'm going to be in biotechnology now. So what happened? Why?
It's a combination of starting my assistant professorship and realizing, start thinking about what's next. Once there's no more certificate that I can get anymore. So it's like, what's the measure of progress?
What's next?
What's the measure of impact? What's next? And then AI machine learning kind of area started to bloom, and like many kind of academics started to spin out companies thinking about application for AI in the real world. That was kind of very, very interesting for me. And then a third personal reason, so my mother passed away for cancer a year before, and I was very driven by kind of making an impact before I pass away. And
You still have a long time,
yeah.
right?
So it was, yeah, just the right timing, I think.
Now, okay, but then that's not an obvious thing, right? You might be understanding algorithmic science because you've been at it for a long time, but then suddenly you've got to switch gear and go into a completely different domain. How do you acquire the domain expertise, and how do you marry the two?
That's actually what I love about it. It was a very, very steep learning curve, and I just enjoy every single minute of it. Because in academia, you start your assistant professorship and you kind of like, you saturate pretty much. You're just doing whatever you're doing, and that's pretty much it. When you jump into a totally new area, you just have to learn everything on your way. And for me, it was a combination of scaling myself and reading and learning and talking to lots of people, and then making sure that I have a team around me who can kind of fill in all the gaps. So building the right team, delegating as much as possible to the expert in the area, and then getting myself up to scale to kind of be also on board on that.
So do you have among your co-founders people who come from the biotech industry?
So I have my co-founder is a physicist, so he's been in academia 15 years doing physics, and I have my head of chemistry from the pharmaceutical industry. She's been about 20 years in the pharmaceutical industry, right, innovating and designing drugs. And then I have a VP of engineering from Quantum Black, McKinsey, who's been also in kind of the engineering side for some time. 12 people in my team have PhDs in physics, machine learning, and chemistry, so kind of like super smart people, kind of feeling in, yeah. It's a very interesting environment.
And for you, Derik, it's I guess the same story. You, when you started Osaro, you could have gone any place with this technology. Mm-hmm. But then you decided to target industrial robotics, and yet you were nothing like an expert in robotics, not at all, as a matter of fact. So
I studied physics, and everything obeys the laws of physics.
Right. so you were not scared?
Well, no, but that was naivety. If I actually had known, I would have been scared. So we did start with some domain expertise. So again, we have a perception and control stack. The perception element, my co-founder and CTO built chips before. He was at Samsung scaling all of their CMOS sensor integration, so phones for your cameras. And we had a vision for the technology, which was that as Moore's Law continues to progress, whether it's existing chips, GPUs, or new chips, as the algorithms advance, as we get more data, eventually, in principle, it is possible that you could have essentially a cell phone and you point it at a robot and that algorithm learns how to control it. So we knew that was all starting to happen. My co-founder had an expertise in cameras, and then we went out and hired a team that had expertise in deep reinforcement learning, and then eventually, as we got deeper into the problem, you need even more domain expertise, and so you hire very specialized people. As far as why did you industrial robotics? Eric showed the slide earlier, and others have talked about it. Around 2013, 14, AlexNet surpassed humans in visual performance, and at the same time, robots like cars have essentially been flat in price, but around 2012, the average wage of a worker in an industrialized country surpassed it. So this difference here can be captured by an algorithm, essentially. If you have a very highly repetitive task, you put a cheap sensor on it, and you can capture that difference.
Right, and now, and interestingly, now you're a deeper domain expert in the space than most, right?
Oh yeah, well,
right.
And that's because most of the people who were in the space were using old-style technologies, and I think it's kind of this classic disruption.
Yeah, that's kind of what's interesting, right? You start from very deep tech, and then you learn the ropes, so to speak, and then you become a better domain expert because you're asking questions that no one else is asking.
Right.
I guess it's the same for you, Alex, right?
Yeah, I mean, it's kind of like the beginner's mind is more open than the expert's mind in many ways. And, we make software that is used by retailers, banks, insurance companies, and yet nobody at the company is a banking, insurance, or retail expert. what we've created is a horizontal platform where it's not an industrial robot that you create a robot for a cubicle, but it uses artificial intelligence technology to essentially get at parity of experience for an operations team. So if it takes 6 or 8 weeks to train a new employee, and if it takes 6 to 8 weeks to train a robot, then we're looking at economics of software versus economics of people, and kind of looking at the problems through that prism is not something that many people did before.
So, and when you say not many people do it, then I want to ask the obvious questions. In RPA, it's a robotic process automation, which is the business of automating enterprise workflows. You've got major competition, and the usual suspects, Blue Prism, UiPath, Automation Anywhere. What makes you believe, and I'm going to, obviously it's a leading question, what makes you believe that you can outcompete those guys?
I think ultimately making business processes smarter for enterprise is all about the data that flows through the process. And while there are obviously other companies that are getting at the concept of a robot in the knowledge work, we are known as a company that focuses on the data that flows through the process, and so is able to automate workflows, anti-money laundering in banking or claims processing and insurance by essentially creating smarter bots that learn from the data and adjust to the environment as it changes.
So being smarter, in this case, wins.
Because it reduces time to value. Essentially, rather than creating a bot from scratch that is custom coded for your specific rules, we can create a system that makes that process faster because it has learned how to process this sort of data or a document in another customer. So each next customer benefits from the learning of all the other customers, and so through that it creates a network effect and reduces the value. We have this concept of 1-6-12. In one day you can assess your business problem for whether it can be automated using a software robot. In 6 weeks you can train a software robot, and in 12 weeks you can be live with a new business process that now combines people and robots in one environment.
So we talked about competition here, and that's, I think your answer was compelling. Smarter wins, and then you have a process here. Derik, you've got serious competition, and coming back to some of the talks we heard before, you've got serious competition in the shape, for example, of Amazon, and some well-funded startups like Vicarious. How do you believe that you win?
I plan on just staying focused on customers. I think Vicarious has taken more of a research approach to things, and that was one of the questions I guess we prompted ourselves with. It's the research trap around deep tech. And then in Amazon's case, we're at the point now where much of the ecosystem, and there's not really one ecosystem, many ecosystems, materials handling, e-commerce, online retail, is starting to develop an immune response to Amazon. And part of our strategy has been to capitalize on that. So when we license our software to materials handling integrators, we think of it as arming the insurgents. And we tell them, listen, wouldn't it be great to roll into an Amazon facility with better software than they have? And I've told Amazon, I plan on you buying my software not directly, but through our partners. And you won't even know you're buying it. So I think staying focused on customers and maybe sort of weaponizing some of that immune response is part of our strategy.
Arming the insurgency, I love it. Yeah. Okay, so switching gear again. So I want to talk about how we avoid the research trap. So all of you guys are involved in deep tech. So the business of empowering scientists and technologists and building products upon that. How do you know you're not failing at it? How do you know you're not focusing too much on the research and not enough on a product? Paul.
So since we're in Silicon Valley and my CEO is Gordy Campbell, and Gordy's actually famous, you guys can Google him, but he has a philosophy that he's distilled over many, many years, and I'm in complete agreement with it. If you are a startup and you think you have a critical piece of technology of value, then you should be able to find somebody, a launch customer, somebody who's willing to bet upon it. And by doing that, you can validate that idea. and accelerate yourself to market.
So what does that mean? So pay for research?
Pay, not for the research, but for the end product. So, and basically, what I say, gravity always wins. And gravity is, where is the money? Where's the revenue? Because, you know, in Startup 101, the first business plan you make in a startup never works, because you never quite know where the value proposition really is until somebody's willing to pay for it. And once you figure that out, you've gotten a lot of the risk out of the way.
Did you take this approach, Noor? Could you do it in your space, pay for productizing research?
I don't think it is straightforward. I don't think there's like kind of a switch where you can say like we're doing product-wise or we're like just doing research stuff. It's more kind of giving, I mean, researchers need kind of this space of mind where they can think and be creative, because that's what keeps them motivated. So you need to find this kind of place where they feel empowered to do innovation, and at the same time they think about the end use of it. So it's a matter of like always asking the right questions. It's like, why are you building this? How are you benchmarking it? What's the path from there to the end point? And do you see that clear path? What's the implication of that? And it's kind of a matter of getting researchers to have these questions in their mind whenever they jump into a new piece of technology. So that's, I think that is for us what's working, like a direct link between research and implications.
And can you give us an example in your mind of what that 8 point is?
So we have, for instance, like usually we have a number of approaches that we can try on to kind of get like say predictive models, like predicting potency endpoint for certain drugs to work. And we usually try like, we have like some research coming up and we would like to try it, but we have a piece of technology that's already working and we know it's good enough. So if you would like to try this nice piece of shiny method that is almost working in academia on this new existing problem, what's kind of the benefit that you're expecting? Is it significant? Is it kind of just an incremental step? Is now the right time to do it? What is the timeline between that piece also being kind of improved in academia before we bring it on board? So it's kind of like these kind of questions, and having everyone in the team kind of sitting together and thinking about when is the right time to try what.
And coming back to the kind of diseases you're trying to solve or cure, in your case, what do you believe is going to be the first?
The first cure.
The first cure.
First cure.
Yeah.
It's hard to tell. We have now a number of programs that are going on in oncology and neurodegeneration. So basically cancer, Alzheimer's, dementia, Parkinson's, all very challenging.
Big ticket items.
Yeah, all very challenging. So it's hard to tell where the technology is going to be like, where the first cure is going to come from. But I do believe that we have a piece of technology that has the potential to really disrupt how we think about protein target, about biology of the protein, and how to kind of target specific states in the kind of protein life cycle that allow us to build way better medicines.
Okay. How much time do we have left, folks? 2 minutes? All right. So I want to ask one last set of questions. Or perhaps, do we have time for a question, perhaps? Does somebody want to ask a question in the audience? Before we get to my last question. All right. So my last question is, so when it comes to deep technology, we're always conflicted as to how to apply it. By definition, it can be very horizontal, right? Paul, in your case, you could apply your hardware architecture to pretty much any problem that is parallelizable. So how do you make a choice? And how do you resist the temptation of knocking one vertical, knocking the second vertical, the third vertical all at the same time, and instead focus? So we all know startups win by focusing. How do you guys get to focus? Who wants to answer this?
Well, I can take a crack. I think in order, our company is in the software business. In order to be a viable software supplier to enterprise, you have to get to a degree of scale. And so each software company has to navigate that stage where you have to create more massive, simpler, more mass appeal product that in a way keeps no customer 100% happy, but makes all of them together benefit from having a more reliable company that ultimately brings more innovation to the table. And in doing that, it's critical to go segment by segment and create a whole product in each segment before you move on to another one. Otherwise, nobody is happy, and so you solve nobody's problems in doing that. And so a lot of companies kind of try to do that, but also there is a flip side to that argument that you could become a hostage to one segment and get big customers who demand you to add more and more and more and more features, and so you never move on to another segment. So it's a delicate balance, but ultimately that's what's responsible for escape velocity.
Anybody else wants to comment on this?
I'd say a couple good heuristics would be don't move to another customer/vertical until you've stabilized your product. You have essentially a repeatable sales process. You've got a support process is probably one. Another is that it's okay to tackle other domains, but you want to be reusing as many of your components as possible. So if you're having to reinvent a large part of your stack each time, then it's probably not worth it.
I toss an extra thing. So when there's a customer trap, if you ask your customer what does he want next, he's always going to tell you what he currently has with features added on. And if you're dealing with a set of disruptive technologies, you have to lead that particular market. Yeah. So you're going to have to be able to answer the question a month, 6 months, a year, 18 months ahead of what that customer is going to want. And that's hard to do.
All right, I'd like to thank everyone here, Noor, Paul, Derik, and Alex, for volunteering your thoughts and making this panel a very interesting one. Thank you so much. I hope you guys will enjoy the rest of CogX. Thank you so much.
Thanks so much.